In the last lesson, we looked at the two special triangles that have degrees 45, 60, and 30. So here is a review of what we covered in the last lesson. And I wanted you to remember these triangles or memorize them after we figured out where they even came from, mainly because this will definitely expedite you to do questions in the future. Not only that, but you see in the corner here, this says number 3. I also want you to remember specific parts of the unit circle, not all of it because it is a lot of information. More specifically with the degrees of 0 degrees, 9 degrees, 180, and 270, because we can determine what cos of 0 degrees is or sine of 180 degrees is by knowing the points on the unit circle 1, 0, 0, 1, negative 1, 0, and so on. And that the first coordinate, the x value, represents cos of some angle, and the second value, the y value, is represented as sine of some angle. I also, if you take a look at the other tab here, I put in a little summary of what I want you to memorize. You can definitely write this on a separate piece of paper, like on a piece of loose leaf, so you have this available to you. And every time that you need to write out an assignment or a test or something, it's always good to write this on the side. Now, you should have this memorized. I wouldn't want you to rely on this sheet every time you do a question. I actually want you to write this out for every question that you do or whenever you need it. Just because if you do have to write a test, there won't be any cheat sheets or anything like that where you can actually look off of this stuff, and there won't be anything on the formula sheet for you to look at this stuff. So that's why I want you to remember it and memorize it, so that you can utilize all this information and apply it to other questions in the future. And we already explained how these came about in previous videos, so if you forgot how these things even came about, then I would watch those videos again for the full explanation. But in this memorize this section, there are the two triangles I want you to remember with its angles and sides, and then again, the specific points of the unit circle that can help us determine what cos 0 degrees is, sine 0 degrees is, cos 9 degrees is 0, sine 90 degrees is 1, and so on. And then, of course, remember your cast, which determines what quadrants are positive and negative, depending if it's sine, cos, tan, or all. Okay, so we're going to go back to page 14 in the notes, and we will do questions that are related to what we just learned that's based off of this stuff. So if you don't have those things memorized or know how to find the basic sine 30 degrees, cos 60 degrees, then you are going to struggle with this next section here because it is an extension of that. So if you are not comfortable with finding what cos of 45 degrees is right now, then I would go ahead and review this again, watch the last video again, do the practice questions before you move on to this, because I know this is a lot of information. Alright, so here's an example 1. It says determine all the trig ratios of all the angles that have a 30-degree reference angle. So saying all trig ratios, that means we're going to look at sine, cos, and tan. Those are 3 trig ratios that we are going to concern ourselves with. And we also need to find all the angles that have a reference angle of 30 degrees. So the first thing I'm going to do is find all those angles with 30 as a reference. So I'm going to consider each quadrant then. So in quadrant 1, it's going to be 30 because it's an angle between 0 and 90 degrees. For quadrant 2, this has to be an angle between 90 and 180 degrees. And to find an angle in quadrant 2, it's going to be 180 minus the reference angle, which is 150. And if you forgot about all these rules, refer back to page 9, because that's where we stated all of them. Okay, we're going to go to quadrant 3, which is an angle between 180 and 270. So that'll be 180 plus our reference angle, and that's 210, and then lastly, an angle in quadrant 4 is 360 minus our reference angle, which is 330. So those are our 4 angles. And we're going to now look at our trig ratios for each quadrant. So I'm going to focus now on quadrants specifically. We're going to focus on quadrant 1 first. And this is where all of your ratios are going to be positive because it's in quadrant 1. Sine, cos, and tan are positive in quadrant 1. So then we're going to do sine of 30 degrees, cos of 30 degrees, and tan of 30 degrees. Because we're looking at 30 degrees, you're going to need your 60-30 triangle. So you can determine what those ratios are. So here's our triangle. If I'm looking for sine of 30, I'm going to use 30 as my reference. And then sine is opposite over hypotenuse, which is a half. Now we're going to look at cos 30, which is adjacent over hypotenuse. Our adjacent from 30 degrees is root 3. Our hypotenuse is 2. And then lastly, for tan of 30, this is opposite over adjacent. Our opposite's 1, our adjacent is root 3. So we're done, quadrant 1. Now we're going to look at quadrant 2. And quadrant 2, my angle is 150 degrees. So that's sine of 150, cos of 150, and tan of 150. It's going to be the same ratio as the ones that we have in quadrant 1 because the reference angle for 150 is 30. So it's going to have the same exact value, but the only thing that changes is its sign. Because for quadrant 2, this is where sine is positive, which means that cos is negative here, and so is tan. So we're just going to put a negative in front of the cos 150 and a negative in front of the tan for the tan 150. Moving on to quadrant 3, this is where tan is positive, which means that sine and cos are negative here. So we're looking at sine of 210 because 210 is the angle in quadrant 3, cos of 210, and tan of 210. Again, they're going to have the same numerical ratio as the one in quadrant 1 because your reference angle is 30 degrees for 210. The only thing that changes is its sign because we are in quadrant 3. So the only one that's positive is going to be tan, and then sine and cos are negative. So I'm going to put a negative in front of a half and the negative in front of root 3 over 2. Lastly, we're going to look at quadrant 4, and this is where cos is positive. So then we're looking for sine of 330, cos of 330, and tan of 330. Again, the same ratios as the one in quadrant 1. The only thing changes is that cos is positive and then sine and tan are negative. So it'll be negative a half and negative 1 over root 3. And then we are done with this question. For the next question, to the nearest degree, which values of theta satisfy the equation tan theta is equal to negative 4 over 3 for angles between 0 to 360 degrees. The first thing we're going to do is determine what quadrant we're actually in. And we can determine this because there is a negative in front of this 4 over 3, which means that tan theta is negative. Tan theta is negative in quadrants 4 and 2. and that's directly coming from cast. So if you forgot about that, I'm just going to write this on the side. So tan is only positive in quadrants 1 and 3, which means it's going to be negative in quadrants 2 and 4. So that means we need to find angles in quadrants 2 and 4. Before we do that, we need to find the reference angle first. And to find an angle when we're already given the ratio, we're going to take tan inverse of both sides. In other words, I'm going to take tan inverse of 4 over 3. So as a side note here, notice I didn't indicate that negative with the 4 over 3 because we are already considering that by its quadrant. We're going to take care of that when we figure out the angle quadrants 2 and 4. So notice no negative. You already accounted for this. In part 1 of this question. Okay, so I'm going to put this into the calculator. Tan inverse of 4 over 3 in the calculator gives me 53 degrees. This is our reference angle. Next thing we're going to do is find the angles that are in quadrants 2 and 4 using this reference angle. So in quadrant 2, we find angles in quadrant 2 by taking 180 minus our reference angle. So this is 127 degrees. And then for quadrant 4, we can find an angle in there by taking 360 minus our reference angle, which is 307 degrees. So our final answer then, theta is 127 and 307. Moving on to the next example. It's kind of similar to the one we just did. This time we're looking at cos theta is equal to negative 4 over 5. And we're going to determine the other primary trig ratios of the angle theta. And then to the nearest degree determine the possible values of theta. So I'm going to answer the first question here. I'll call this A. And this one here, I'm going to call this B. Two parts of this question. So just for A, we need to determine the other trig ratios, which means I need to find sine theta and tan theta. We're already given cos theta is equal to negative 4 over 5. We know that for cos, this is an adjacent side, and this is a hypotenuse. So that means we need to find the opposite side, and this does create a triangle. So we can use Pythagoras to solve for this. And also this negative in here indicates what quadrants we're looking at. We're looking at quadrants 2 and 3 because cos theta is negative there. So first off, let's just say that we have an angle in quadrant 2, and this is our angle. The adjacent side is 4, our hypotenuse is 5. Again, this could also be drawn in quadrant 3 as well because cos theta is also negative in quadrant 3. It really doesn't matter. I just want to find the missing side here. So if you know that this is one of our special triangles, this is a 3, 4, 5 triangle, but if you didn't know that, you could use Pythagoras to solve for the missing side. So you could have done this. And once you solve for that, you're going to figure out that A is 3. So that is going to be our opposite side. 3 here. So then if I'm looking for sine theta, we know sine theta is opposite over hypotenuse. And our opposite in this case is 3. And our hypotenuse is 5. Then for tan theta, this is opposite over adjacent, so that's 3/4. And these are our ratios for some angle. We don't really know if it's in quadrant 2 or 3, but it's not enough information given to us, so I'm just going to leave this as is, assuming that the one for sine is in quadrant 2 and the one for tan is in quadrant 3, which makes them positive. But if we were given more information, we can determine if sine theta or tan theta is negative there. Moving on to the next part of the question, we want to determine that degree now. So then this is the question that's exactly like question 2, this one here, and we're going to do exactly the same thing, determine what quadrant it's in, and we already stated that cos is negative in quadrants 2 and 3. We want to find the reference angle using our calculator and then find those quadrants, or find those angles within those quadrants. Okay, so the first thing I'm going to do then is determine what quadrant it's in. It's going to be in quadrants 2 and 3 because cos theta is negative there. And we know it's negative there because we have a negative that's given to us in the question already. Okay, the next thing I'm going to do is find the reference angle. And I would take inverse cos of both sides. So I'm taking cos inverse of 4/5. Again, remember, do not include the negative because we already considered the negative from part 1, which is when we determined which quadrant it's in. So once I put this into the calculator, I'm going to get about 37 degrees, just rounded to the nearest degree. Then I'm going to find the specific angles in quadrants 2 and quadrants 3. So to find an angle in quadrant 2 is going to be 180 minus our reference angle, which is 143. And then to find an angle in quadrant 3, that'll be 180 plus the reference angle, which is 217. So our angle then is 143 and 217. Our very last example. Given that cosecant is negative 13/5, determine the other 5 trig ratios of the angle theta. Now here's a little side review if you forgot what cosecant is. Cosecant theta is the same thing as saying 1/sine theta. We could also say that this is hypotenuse over opposite. So this is a reciprocal function of sine. There's also secant. So if there's secant theta, this is 1/cos theta, which is the reciprocal of our cos function. And if you want to find our specific sides, you can use hypotenuse over adjacent here. And lastly, there is cotangent theta, which is the reciprocal function for our tangent function. And if you wanted to find specific parts of cotangent theta, usually tan theta is opposite of adjacent, so cotangent is adjacent over opposite. So here is a side note of the other trig ratios that we can consider. Now going back to example 4, we want to find the other 5 trig ratios of the angle theta. So we're going to look at cosine theta, and this is similar to sine theta in that sine theta is positive in quadrant 2. Cosecant theta is also positive in quadrant 2, which means that it's negative in quadrants 3 and 4. Now this side here is our hypotenuse, and this side here is our opposite, according to our rule about cosecant theta. So we know what the hypotenuse and the opposite is, we don't know what the adjacent is first. So I'm going to call this question A, and then the other one is another question, question B. So for question A, we are going to try to find sine theta, cos theta, tan theta, secant theta, and cotangent theta. So we already know what sine theta can be, because sine theta is opposite over hypotenuse. We know what the opposite is 5, the hypotenuse is 13, and because cosecant is negative, so is sine, just because they are reciprocal functions of each other. Now to find cos, we need to find the adjacent. So if I'm thinking about just some angle here, and I already know the opposite is 5, the hypotenuse is 13, I do want to find that missing side to get the adjacent side. If you solve for this, we can use Pythagoras. And once you solve for this, you're going to realize that B is going to be 12, which is our adjacent side. Okay, so we know cos theta is adjacent over hypotenuse, so that's 12 over 13. And now we don't really know what quadrant it's in. It could be in quadrant 3 or 4 because cosecant is negative. I'm just going to assume that maybe this thing is in quadrant 4 for this one, and then when I'm doing tan, I can just assume it's in quadrant 3 so that they can both remain positive. So for tan theta, this is going to be opposite over adjacent, which is 5 over 12. Then I'm going to look for cotangent theta, and this is adjacent over opposite. Our adjacent is 12, our opposite is 5. And then for secant theta, this is hypotenuse over adjacent, which is 13 over 12. And those are our 5 trig ratios. Moving on to part B of this question, we want to determine the possible values of theta. Again, it's very similar to the questions we've done already from example 2 and part B of example 3. So the first thing I want to do is find what quadrant it's in. And we already stated that it could be in quadrants 3 or 4 because that is where sine is negative, or in other words, cosecant is negative. The next thing we're going to do is find the reference angle. In this case, you're going to be careful because if you look at your calculator, you don't have a function for cosecant. So we are going to have to rewrite this in terms of sine. So cosecant theta is negative 13 over 5. And if you look at how we rewritten this in sine, just on part A, we determine that sine theta is negative 5 over 13. So that's what we're going to use to help us find the reference angle. We're going to use this sine version of it. So for our reference angle, it's going to be the sine inverse of 5 over 13. Remember the negative, we already counted for that from part 1, which helped us determine which quadrant this angle is going to be in. So I'm going to plug in sine inverse of 5 over 13 in the calculator. We're going to get about 23 degrees. I just rounded it to the nearest degree. So now that we have the reference angle, we can find the two angles, one in quadrant 3 and the other one in quadrant 4. So an angle in quadrant 3 is going to be 180 plus the reference angle, which is 203, and then to find an angle in quadrant 4, it would be 360 minus our reference angle, which is 337. So then our final answer is 2 3 degrees and 337.